Health webcast, Understanding Electric Arc Flash, sponsored by Ergodyne. My name is Kyle Morrison. I'm the Senior Associate Editor with Safety & Health magazine, and I'll be moderating today's session. Thank you for joining us. We'll start the presentation in a few minutes, but first I'd like to go over some housekeeping items. The views of the speaker and her organization are her own and do not necessarily reflect those of the National Safety Council or Safety & Health magazine. Mention of any commercial enterprise, product, or publication does not mean the Council or the magazine endorse them. At the end of today's webcast, we'll have a question and answer session. To ask a question, simply type it in the text box located in the lower left-hand corner of your screen, then click the Submit Question button. You can feel free to ask your question at any point during the presentation. You don't have to wait for the Q&A session to begin to ask your question. We'll try to answer as many questions as possible, but due to the large number of participants today, we may not get to all of the questions. However, all unanswered questions will be forwarded on to today's speaker. For basic troubleshooting information, please click the Help button located on your screen. At the end of the webcast, you'll be asked to complete an evaluation survey, and I'll talk a little bit more about that after the presentation. This webcast will be archived for 3 months, so you can access it after today's live presentation. Within about a day, just simply use the exact same URL that you used today to access the archived version. All right, with that, I think we're ready to begin. Our speaker today is Adria Hardy. As Ergodyne's product manager of the Elements pillar of products, Adria uses her knowledge of the basics of FR personal protective equipment, industry hazards, FR labeling, and industry regulations and standards to help protect workers. Adria?
Thanks, Kyle. And thank you all for joining us today. As Kyle mentioned, my name is Adria Hardy, and I am one of the product managers here at Ergodyne. Today's purpose of the webinar is to really give you all a better understanding of what electric arc flash is, give you an understanding of regulations and standards built to protect against it, and then we'll talk a little bit about how you can implement a compliant PPE program. So let's go ahead and jump right in and get started. Electric arc flash is a very serious hazard that can cause major and minor injuries, permanent disability, or even death. And if you see a few of the stats on the screen here, there are 5 to 10 arc flash accidents that happen every day in the U.S., and we have more than 3,600 disabling electrical contact injuries that happen each year. Just in 2012, there were 156 workers that unfortunately died due to exposure to an arc flash. And fatal burns can actually occur even when the victim is just several feet from an arc, even up to a distance of 10 feet away from the blast site. So it's an extremely powerful exposure. So let's start with the basics. There are some basic terms that are very vital in understanding FR apparel and arc flash. So what is FR, or flame resistance? It's a term I'm sure all of you have heard or maybe used. If something is FR, it means that it will resist flame ignition and self-extinguish a flame. I just want to note that just because something is labeled as FR does not necessarily mean that it's going to offer arc flash protection. And actually, the standards have changed some of their language to reflect this, where you'll start to hear, instead of a garment being called an FR garment, it will be called an AR garment, or arc resistant garment, because there is a difference there. So it's really important to verify what standards that PPE that you're using is compliant to, so that your workers are protected from the correct hazards. And flame resistance is very oftentimes confused with flame retardant, which is a different term typically used to describe a chemical substance that imparts some sort of flame resistance on fabric. So typically a flame retardant product uses, you'll see, a single wash topical treatment, most likely in the case of some sort of accessory product. There are 2 types of flame-resistant apparel. The first one is primary protective clothing, and this clothing is designed for applications where there's significant exposure to radiant heat or flame that's likely to occur. So a great example of this, you see here a picture of a firefighter. It's going to be turnout gear or possibly an aluminized suit. And then the second is secondary protective clothing. And this clothing is designed for continuous or daily wear in areas where there may be occasional exposure to that radiant heat and or flame. It is possible to happen. So keep in mind that the protection achieved by any secondary protective FR clothing can be negated by an overwhelming arc exposure. That secondary protective clothing does not guarantee that a worker is going to walk away unscathed from an incident, but it's definitely going to help to provide some protection. So why should a worker wear FR daily wear clothing? There are really three key reasons. The first one, FR clothing makes an incident survivable. Number two, FR clothing saves an employer money. And number three, FR clothing keeps an employer compliant. Digging in a little bit more into the details, number one, it increases a worker's chances of survival. FR clothing makes an incident survivable by limiting body burn injuries to less than 50%. And you see on your screen a burn survival chart here. And this shows that if a person has less than 50% body burn, no matter what their age is, their survival rate is almost double that of a person with 75% body burns. FR clothing is made to self-extinguish the flame and provide a barrier insulating the wearer from some of that radiant heat. So these in combination help to limit that person's injury. FR PPE does not guarantee that a worker is going to walk away unscathed from an incident. However, it does provide a worker with precious escape time from an ignition source, and that also helps to greatly increase their chance for survival if they are caught in an electric arc flash. The second reason why you should be wearing FR PPE, FR clothing, because it saves money. The cost of an entire FR clothing program is going to pale in comparison to any medical or legal costs that you may incur because of a severe burn injury. And I've noted some stats here on your screen. I mentioned earlier, with 5 to 10 arc flash accidents that occur every day in the U.S., this is a dangerous hazard that does really happen, and when it does occur, no matter how insignificant, it will result in significant costs to an employer. Some of the stats, the average cost of medical treatment for an arc flash is $1.5 million. It's also costly to have lost work days. Workers could be out for 8 to 12 months after an incident, and of course then there's the possibility of a worker death or a permanent disability, and that can cost an employer $10 to $15 million per litigation. So employers really should view FR clothing as a very critical part of their insurance policy. And then number three reason, FR clothing keeps an employer compliant. The bottom line is that FR clothing is required in industries where electric arc flash can occur, and that responsibility is placed on the employer to conduct what's called a hazard risk assessment, and they are responsible for determining what PPE is appropriate. OSHA can and does fine employers who fail to provide proper safety equipment to their workers. So not complying with the laws can leave your company open to fines from OSHA and litigation from other sources. So what is an arc flash? An arc flash, sometimes called an arc fault or an arc blast, is a dangerous release of energy created by an electrical fault. And it can occur in any of the following ways you can see on your screen. Coming too close to a high amp source with a conductive object can cause that electricity to flash over, causing an arc flash. Dropping a tool or otherwise creating a spark that can ignite an arc flash. Equipment failure due to the use of substandard parts, improper installation, or even normal wear and tear. Gaps or breaks in insulation. And then dust, corrosion, or other impurities on the surface of a conductor. An arc flash incident will produce an explosive blast, and with that blast it produces each of the following things. The first, it's going to produce some major heat. An arc flash can reach upwards of 35,000 degrees Fahrenheit, and that's 4 times hotter than the surface of the sun, so it's an extremely intense blast. Second, it's an intense light. You'll see an intense light. That oftentimes can disorient the worker in the blast and can even lead to blindness, whether that be temporary or permanent. Third, it can produce acoustical energy or a very loud noise. And that loud noise can actually deafen a person or even lead to permanent hearing loss. Fourth, it produces a major pressure wave. blast pressure waves have thrown workers across rooms, knocked them off ladders. The pressure on the chest can be as high as 2,000 pounds per square feet, so very intense. And then lastly, it produces debris or flying molten metal. Because of that immense heat, that intense heat that I talked about earlier, arc flashes have been known to literally vaporize solid copper wires. So you can see in the picture on your screen here, those little tiny specks, that's actually molten copper debris that's being spewed onto that worker as that blast is going off. There are several applications where an arc flash can occur, most notably electrical and utilities, but it can also occur in other applications like railways, manufacturing or operations, and production environments. Implementing an FR program, including wearing appropriate PPE, will reduce injury. It's going to save you money. It's going to keep you compliant with the law. And really, there's no worker that's ever been injured or killed by an arc flash when they've been working in an electrically safe work condition. So how do you prevent an electric arc flash in the workplace? We always look to NIOSH's hierarchy of controls. NIOSH is the National Institute of Occupational Safety and Health. For those of you not familiar with how this hierarchy of controls works, basically you can apply this to any occupational hazard that may exist in the workplace. It helps to control exposures to those hazards using a fundamental method of protecting workers. So traditionally, a hierarchy of controls has been used as a means of determining how to implement feasible and effective controls. So the idea behind this hierarchy is that the control methods at the top of the list are going to be much more effective and protective than those towards the bottom. So if we start at the top of our pyramid, they mention elimination and substitution. While these are most effective at reducing risks, they oftentimes tend to be the most difficult to implement if you have an existing process in place. If that process is still in the design or development phase, then elimination and substitution of hazards may be more inexpensive and more simple for you to implement. For an existing process, major changes in equipment and procedures may be required to eliminate or substitute the hazard. If we relate these to an arc flash, there are a few questions that a safety manager should ask themselves. You see them listed here on your screen. Number one, can jobs be scheduled so that power sources can be de-energized, grounded, and tested, therefore eliminating the hazard? Or can an outdated or worn piece of electrical equipment be moved from service, or can a newer, safer model replace it? Answering these two questions and looking at what you can do to help these are two really great examples of how you can use elimination or substitution controls when related to arc flash hazards. Moving down our pyramid, the next one is engineering. Engineering controls are meant to block the worker from the hazard. So some great examples of this as we look to arc flash protection: engineering barriers to dangerous locations, locked electrical vaults, and high fences around transformers. These are all really great examples of some very good engineering controls that you can put in place to protect workers. Moving down then to the middle of the pyramid, administrative controls. And administrative controls include any procedures that significantly limit daily exposure by control or manipulation of the work schedule or manner in which that work is performed. So an example of this related to arc flash would be an effective lockout-takeout program. And that would include all necessary training and equipment needed to implement it. Again, just a perfect example of an administrative control. Another one would be warning labels on equipment. That also can be a really great administrative control to put in place. And then last in the hierarchy of controls, personal protective equipment, or PPE. When exposure to a hazard cannot be engineered completely out of normal operations or maintenance work, and when safe work practices and other forms of administrative controls cannot provide that additional protection, then a supplementary method of control should be used, and that is really in protective clothing or equipment. And that collectively is called PPE, or personal protective equipment. Now, PPE for arc flash is really the last line of defense. Like I said earlier, it's not intended to prevent all injuries, but it is intended to mitigate the impact of an arc flash should one occur in at your site. So you're probably saying to yourself, I get it, I got to wear some FRPPE, but where do I start? Where should I begin? Well, first, it's important that you understand what the standards require. And that's what I'm going to talk about next. So let's look at federal OSHA. Federal OSHA places responsibility on the employer for all aspects of workplace safety with that general duty clause. And we're all very familiar with what that is. But this means that an employer must know what fire hazards exist in their workplace, and then they need to put the proper controls in place to protect their workers. If we look at OSHA's Code of Federal Regulations, there are two sections that very broadly mention FR clothing. Section 269, it states that clothing for employees exposed to arc flash or flash fire hazards cannot add to injury. And this section actually prohibits the use of synthetic fibers. So we're talking nylon, polyester, rayon. So any worker that's going to be in an arc flash, it could be exposed to arc flash, they should not be wearing any sort of synthetic fiber clothing. And then the second section is 132. And this section gives more of a general requirement for workers to identify hazards and then provide their appropriate PPE. So again, an employer should be conducting some sort of hazard risk assessment to identify those. While OSHA does not mandate compliance with any standard, there are nationally recognized consensus standards from organizations like NFPA, which is the National Fire Protection Agency, and ASTM, which is the American Society for Testing and Materials. And oftentimes, these nationally recognized consensus standards are used as evidence of best practices being followed, considering that general duty clause citations. So, let's dig into what those are. There are really three main recognized consensus standards in the U.S. that surround FR clothing for arc flash applications. The first one is ASTM F1506. This is the standard performance specification for textile material for wearing apparel for use by electrical workers. Say that 10 times fast. And then NFPA 70E, or the Canadian equivalent, which is CSAZ 462, which I will touch on very briefly for any friends of the North here. And that's the standard for electrical safety in the workplace. And then we have the NESC, or the National Electric Safety Code. So starting with ASTM F1506, this is a performance standard that lays out everything that a manufacturer needs to know about labeling, testing, and the design of a garment. So it's everything that Ergodyne would need to know as we design our garments. A garment that meets ASTM F1506 complies with that OSHA 1910 Code of Federal Regulations, Section 269 that I talked about, where you cannot be wearing synthetic fibers. And then it also is going to comply with NFPA 70E. The fabric must undergo a series of flame and heat testing, and then the garment design requirements must be followed in order to be self-certified to the standard. So an example of some of those design requirements: thread must be made with using FR fibers. Also, any hardware, so we're talking zippers, hook and loops, buttons, snaps, all of those cannot come in contact with the wearer's skin. So they need to be covered with a layer of FR fabric, both on the outside and the inside. There is no third-party certification that's required. As long as everything passes the testing and then meets the design requirements as outlined in ASTM F1506, then that garment meets the standard and is self-certified. There are really two main tests involved in meeting the performance requirements for ASTM F1506. The first one is ASTM D6413, which maybe some of you are familiar with. This is the vertical flame test. It requires a sample of flame-resistant fabric to self-extinguish in less than 2 seconds after flame at a 6-inch char length. That means the fabric also cannot melt or drip. So again, that's why synthetic fibers are not going to pass this test, because absolutely polyester is going to melt and drip. And then the fabric must still withstand these requirements after 25 washes and 25 dries. You can see two pictures listed here on your screen. These are actually of the same fabric in the vertical flame test. You can see that the flame self-extinguishes. and did not melt or drip after it was subjected to a Bunsen burner, but what you don't see is that time elapse of 2 seconds, and so therefore the fabric did pass that test. The other main test is ASTM F1959, and this helps determine an arc rating or arc thermal performance value, or what is commonly known as ATPV. This ATPV rating is measured in calories per centimeter square, and there are only 2 places in the world that have the equipment to perform this testing. There's a company in Canada, and then there is another one in Spain. Both of these facilities have accredited programs able to perform this testing. The purpose of ASTM F1959 testing is to determine how much heat a certain fabric, or it could be a series of layered fabrics, which I'll talk a little bit more about later. So it determines how much heat will block on a certain fabric will be blocked from an electric arc after the onset of a second-degree burn for the wearer. So survival rate for folks with second-degree burns, like I said earlier, is much higher. So that's why that 50% body burn is kind of the marker there. NFPA 70E requires workers in certain situations to wear garments with a minimum ATPV rating. Another way too, other than ATPV rating, I want to note is sometimes you'll see EBT rating. EBT rating is the break open threshold energy. It's just another unit of measure, but it's still providing you with the same information. So EBT, ATPV, pretty much interchangeable. While ASTM F1506 is a garment standard meant to help manufacturers like Ergodyne test and design PPE, NFPA 70E is not a garment standard. This is for, it really outlines guidelines for workplace electrical safety, of which garments are simply a small component of that. So it's really for end users. NFPA 70E has been around since 1979 and really has evolved to be more of the North American standard for electrical safe work practices for energized electrical work. And NFPA 70E, just to note, does not apply to utility workers. That's another standard, the NESC, which I'll discuss in a little further slide. NFPA 70E is designed for end users to implement safe work practices around electrical hazards. And NFPA 70E contains 5 hazard risk categories, or HRCs. Each HRC level requires a worker to wear garments or PPE with a minimum ATPV or EBT rating, as I talked about earlier. And that's kind of how the 2 standards, ASTM F1506 and NFPA 70E, kind of come together. And you can see the 5 levels here. Approximately 85% of arc flash applications require HRC level 1 or 2 protection. There are some significant changes that have been proposed to take place with the NFPA 70E 2014 revision, and the biggest change stems from one global theme, and that is you either have an arc flash hazard or you do not. You can't reduce the risk, but you can significantly you can reduce that risk, but you can't significantly reduce or minimize the arc hazard. The hazard's either there or not. So there's some significant proposed language changes that the committee is making just for you all to be aware of, and I've noted them here. The first one is a hazard risk assessment is actually going to change to an arc flash risk assessment. So some language changes. HRC level is going to be changing to arc flash PPE categories. So no longer will you see HRC level 1, level 2. You'll see PPE category 1, PPE category 2. I mentioned this earlier, but FR is a very generic term that oftentimes is abused in the industry, and we just call things FR when they might not necessarily be appropriate for arc flash applications. So the committee has decided to change that. So any place that says FR is going to be changed to ARC rated or AR. So you'll also start to see that as far as garments go. You'll see manufacturers saying that that garment is ARC rated or AR versus just FR. MSHA has actually adopted the NFPA 70E standard, so for anyone that does encounter arc flash hazards. And then lastly, conductive articles, so any metal accessories, watches, bracelets, anything like that should not be worn within an arc flash boundary. So plans to publish this new revision are set for August, September of this year, and then those will actually go into effect January 2015. One more quick thing to note, because we get the question all the time too, is this garment 70E certified? Well, I just want to note there that because NFPA 70E is not a garment standard, there are no flame-resistant products or ARC-rated products that are NFPA 70E certified. So 70E does not specify garment performance requirements, but rather it requires that garments meet performance requirements of ASTM 1506. So you'll actually see that in 70E. Also, neither NFPA 70E or ASTM 1506 requires garments to be certified. So when a garment or a product is certified, it means that it's undergone some sort of evaluation by a third party. So an example of that would be UL. And really the only standard that requires a third-party certification to be compliant is NFPA 2112, and that's a flash fire standard which isn't applicable to arc flash applications. So the bottom line, if you need a product that meets 70E, then you need to look for garments that are labeled with ASTM 1506. So typically it will say that this product meets the performance requirements of ASTM 1506. Just briefly talking about CSA standards, the Canadian Standards Association, or CSA, did develop an equivalent standard to NFPA 70E. It's called CSA Z462. They actually developed it in collaboration with NFPA. It's based on 70E. They developed it back in 2005, so a lot later than when 70E was developed. But it does provide guidance, the same guidance as 70E, on the assessment of electrical hazards, how to design safe workspaces around those hazards, and then it also provides guidance on the selection of personal protective equipment and clothing. There's really nothing different between the 70E guideline related to PPE selection and HRC levels, so it's pretty much an equivalent to the American standard. And then the last regulatory code I'm going to discuss is the NESC, or the National Electric Safety Code. This is published by the Institute of Electrical Electronics Engineers, or IEEE. This standard covers those applications not covered in NFPA 70E, like electrical utility works in public or private electric supply, communications, or railway. So the NESC, like NFPA 70E, sets guidelines for employers on how to safeguard against arc flash hazards. The standard requires employers to conduct a hazard risk assessment to determine what hazards occur and at what level of severity. And it also addresses PPE and clothing. Clothing that's made from synthetic fibers cannot be worn unless that material is ARC rated. And this means that the clothing then has undergone that ASTM 1959 ARC testing that I talked about earlier. So anything that's undergone that will comply with NESC guidelines and should be worn for these applications. So now that you have a good, solid understanding of the requirements as outlined in those national consensus standards like NFPA 70E and F1506, how do you select the right PPE? We look to 70E for that. There are some really, really nice tables in 70E that provide the simplest methods of determining PPE requirements. And they're nice for those of you that have gone through them because they provide instant answers with almost no field data. And the tables provide limited application and are conservative for most applications, which is great. So step one is really to determine the hazard risk category, or HRC, based on the task being performed. So on your slide here, we've just showed a snippet of the pages of charts that they do have available in the standard. So we'll just look at this snippet. If we were to assume that we have a worker that's working on energized parts, including voltage testing on panel boards and switchboards with a minimum voltage of 240 up to 600 volts, then that worker, if we follow it, it would be the last one, the bottom row on your table. then that worker must be wearing FR clothing with a minimum HRC level of 2. You can see rubber insulated gloves. Yes, they need that. And then insulated hand tools. Yes, they need that. The second step, once you've identified the hazard risk category that's required for that specific task, then you need to reference another chart in NFPA 70E, so that HRC chart that I showed a little bit earlier. You see it again here. And this is going to help to select the proper appropriate protective clothing and PPE. So if we use the example from the previous slide, we want to be looking for an HRC level of 2, so that would mean that we would choose ARC-rated clothing with a minimum ARC rating of an 8 cal per centimeter square. And this could include any of the following combinations. They go that far to let you know that you can choose an AR long sleeve shirt plus AR pants or a coverall. They also suggest an AR face shield or arc flash suit hood and AR balaclava, or you can use an AR jacket, parka, rainwear, or hard hat liner. Again, all with a minimum rating of an 8 cal. They also have a more simplified 2-category approach in a table in the annex in NFPA 70E, and this table assures adequate PPE for electrical workers within facilities with large and diverse electrical systems. So the clothing listed in this table fulfills the minimum FR clothing requirements for NFPA 70E and should be used with other appropriate PPE for the hazard risk category. Besides just looking at the level of protection, of course, there are other and very important factors that you should consider when you do select the appropriate PPE. And these include the physical characteristics of the fabric. Is it durable? Is it comfortable? Will my workers wear it? Is it breathable? Garment construction and components. Do they use non-melting zippers and hook and loops? The design of the garment. Which style is going to work best for my work environment? Does it have the storage space that I need for the tools that I need? Also the type of conditions under which the garments will be worn. Are you working in a very hot environment? Then you may want to think about the weight of your fabric. Are you working in a cold environment? Again, might think about weight. Dirty, dusty, that will determine colors. Do you want a dark color so that it's not going to show as much dirt and dust? All those sorts of things. And then, of course, cleaning and maintenance considerations as well. If you're still confused on how to select the appropriate PPE, don't let that confusion delay making a selection on PPE. The national trend is typically a single layer HRC2 daily wear and HRC4 flash gear. And again, like I said, approximately 85% of the applications will require either a 1 or a 2 HRC, but don't let that confusion delay your selection on PPE. Appropriate PPE is so important, not only to protect your workers from death or injury, but also to keep you compliant with the laws. Of course, at Ergodyne, we do offer a variety of ARC-rated PPE solutions for a variety of environments and tasks, including we just have launched a new FR garment line for dual hazard protection from arc flash and flash fire. We also have a line of FR ARC-rated seasonal accessory products like winter liners or balaclavas and cooling bandanas. And then we also have ANSI-compliant ARC-rated high-vis FR vests. So some of you may ask, what if I need a higher level of arc protection, higher than maybe what my garment is today? There are 2 ways that you can achieve a higher level of arc protection. That is, number 1, you can either layer up or purchase a heavier garment. Because, and most people actually want to layer. Layering is actually probably preferred more than a heavier garment. But layered clothing works because there are air gaps between that layered clothing. One thing that some people think is that if I have a shirt that is an 8 cal ATPV rating and I'm going to wear a sweatshirt over it at 10 cals, well then together that system must rate as an 18 cal rating. Unfortunately, simple math just won't work. The only way to determine the exact arc rating is to actually have arc test the layers together. So you would need, the manufacturer would need to undergo ASTM 1959 testing to layer that together to get an accurate rating. And there are some garment manufacturers that have conducted multi-layer ARC testing to help end users, like most of you on this call, find a layered systems ARC rating. And at Ergodyne, we have conducted ASTM F1959 ARC testing on a few of our garments in core performance workwear or FR garments. And here's sort of how they rated. It's kind of amazing. These garments by themselves, so the sweatshirts model 7440 and 7445 actually rate as an 18 cal, and the model 7415 actually rates as a 7 cal. So together, if you were to do simple math, you would think, oh, it would probably meet a little bit of over an HRC 3. But in actuality, again, this just goes to prove about those air gaps and how important those are in protection. So this, when you wear it as a system, actually protects you up to a 48 cal. So you actually receive an HRC level of 4. To wear or to equal this high of an ARC rating with one garment, most likely you need to bulk up and get some sort of garment that has a minimum of 22-ounce fabric, so it's extremely heavy, kind of uncomfortable. So that's really the advantage of wearing a layered system, is that you help to minimize that bulk or weight, but yet you're still able to achieve a higher level of ARC protection. What about wearing non-FR base layers underneath your FR clothing? The NESC does allow a worker to wear natural fibers underneath their FR outerwear, such as cotton, wool, or silk, or you could even wear nothing at all. Those natural fiber options are better than synthetic fibers, like polyester. If you do have workers that are wearing polyester base layers underneath their FRCs, and there is an arc flash event, that polyester will do what it's engineered to do, and that is melt and drip. Even if it's not directly, if it doesn't directly encounter the flame or the arc flash, just from that heat alone, it's going to melt and drip into that person's skin. So for maximum FR protection though, wearing an FR base layer underneath your FR outerwear is going to increase that thermal protection and add those air gaps that I had talked about earlier, which is going to help reduce the transfer of heat and then therefore injury. So up last for today, let's talk quickly about care and fit, which are key to ensuring proper FR protection. There's a list of home laundering do's and don'ts in order to properly care for your FR garments. A quick list of don'ts: do not use fabric softener on FR garments in the washer. That's going to help act as a fuel. Do not use fabric softener sheets in the clothes dryer. That's also going to act as a fuel. Do not use bleach on any FR garments. Actually, bleach is very tough on those fibers and can destroy fabric integrity. Don't wear garments that are grossly contaminated by oils, paints, solvents, or chemicals that leave a combustible residue on the fabric. Do not apply insect repellents that contain DEET to garments. That DEET is going to act as a fuel. And then you should not apply any chemicals directly to the FR garment, including spray starch. A quick list of do's: do wash your FR clothing separate from the home laundry to avoid transferring contaminants or transferring those non-FR fibers to the FR garment, some lint. Do use any liquid or dry detergent that does not contain bleach. You can absolutely dry the garment on low heat or air dry. Do launder garments when they become visibly contaminated with any grease, oil, hydraulic fluid, petroleum product, paint, or chemicals. And then obviously always follow the manufacturer's washing instructions that are printed directly on your garment's label. And then last but not least, how should an FR garment fit? The looser fitting the FR garment, the more thermal protection that clothing system will actually provide. Again, going back to what I talked about with air gaps, air is a very effective insulator. Therefore, maintaining an air gap between the clothing and skin will help reduce the rate of that heat transfer and provide better protection if you are exposed to an arc flash. That said, a loose fit in clothing should be balanced against the hazard of clothing being caught in a moving equipment, obviously. As I close out the presentation for Ergodyne, I hope I was able to give you all a better understanding of electric arc flash, how this is a real occupational hazard, and how awareness and education are really key to prevention. But the learning doesn't stop here. At Ergodyne, we are available to help provide you with an abundance of FR resources and product solutions to help keep workers safe from arc flash. You can see some of our resources listed here, anything from training and webinars to brochures and technical white papers. We're absolutely here to help and would love to partner with you to help you kick off your program. So bottom line, you should always be prepared and ensure that you have the correct controls in place to keep your workers safe and productive. Fatalities and major injuries from arc flashes are preventable. So just make sure that you have that proper FR program in place. And with that, I think, Kyle, I'll hand it on over to you, and I think we will open it up for some questions.
Great. Fantastic presentation, Adria. Appreciate it. Before we get into the questions, I just want to give a reminder to everybody that Adria went over a lot of information here, and it may have been a lot to absorb right off the bat. So we do offer an archived version of this webinar that's currently going on. Within about a day, just use the exact same link that you used to access today, and you can re-listen and re-watch the webinar to catch anything you may have missed. I wanted to remind everybody about the short evaluation survey I mentioned at the top of the hour. I'm pushing it out to everybody now. Please make sure your pop-up blockers are turned off. We're asking you to consider completing this survey that should be appearing on your screen now. Giving us your thoughts helps us improve future webcasts. Your input is very important to make sure that we continue bringing you the best webinars we possibly can. So I hope you take the time to fill out the survey. Again, if you do not see the evaluation survey on your screen, please make sure your pop-up blocker is turned off. All right, well, let's get into some questions here. There is a couple questions here regarding materials that can go on the FR clothing, such as a non-FR logo or patch. Are those allowed?
Yeah, great question. I know a lot of people want to personalize their PPE with maybe a company logo or possibly a worker name. That's a common request that comes around, especially when we talk about FR apparel. The thing is unfortunately the way the FR standards are written for arc flash PPE, really there aren't any specific guidelines on size and materials that are acceptable for use on these products when we talk about logos. What ASTM 1506 does say is that any logos, name tags, or any sort of patches can be constructed with non-FR materials as long as the overall area is minimized on the garment. Again, it's sort of a gray area. They don't provide much more than that. I will say as far as Ergodyne's policy, which is pretty standard in the industry today with among other FR garment manufacturers, we can embroider any FR garments with a company name or our logo, but we recommend that any non-FR logo using embroidery be smaller than a business card size or a credit card size. So again, minimizing that non-FR area. And if you do have something that you want larger, then typically FR thread is going to be used in that case.
Okay, fantastic. What about the chemicals or the properties in this FR clothing? Do they eventually wash out, or,
yeah.
or do they last forever?
Yeah, good question. I think this person is asking about inherent FR fabrics versus treated FR fabrics. And a lot of times we hear that too. Oh, is this fabric inherent or is this treated? And typically when we talk about that, when we apply it to the fabric market, it's typically cited that inherent FR garments won't wash out and that they provide permanent lifetime FR protection. And that treated, typically by a lot of standards, people think that this means that the fabric is treated with something topical or temporary, and then that can wash out. The thing is that inherency isn't the only path to engineering the life of the garment flame resistance. So the bottom line is that all flame resistant fabrics are engineered by humans using chemistry to be flame resistant. So whether they do that at the fiber level in an inherent fiber, meaning they pick certain fiber blends to make that fabric, or if it's done at the fabric level in the case of quote unquote treated fabrics, where then they apply some sort of treatment on there. Either way, the final fabric has been engineered to be flame resistant for the life of a garment if you use the proper laundering guidelines. So really at the end of the day for those on the call, what's important is that you find garments that use reputable, credible fabrics. So what does that mean? That means fabrics that have been, that have performed in the market, they have years of performance in the market, that they have repeated independent laboratory evaluations, meaning that they continue to have quality fabrics, and that's why you'll see a lot of the same names among the garment manufacturers, because these folks do provide lifetime protection, FR protection in their fabrics, and those have been demonstrated through independent lab evaluations and years of performance on the market. So a long answer to basically say no. There are some treatments that could wash out, but I will speak for Ergodyne and our products, and no, ours are guaranteed for the life of the garment.
Okay. So does that apply for, if the garments are professionally or commercially laundered or starched professionally? Does that apply to those situations as well, or should workers avoid professional starching or commercial laundering?
Well, typically those folks, those professional launderings, we're talking a Cintas or someone like that, a professional laundering service, they're going to know what the manufacturer's care, what the manufacturer's care information is going to be. So they'll ensure that the proper laundering guidelines are followed.
Okay. What about? I know we talked about this issue as it pertains to FR, but what about arc resistance or arc flash suit clothing? Can those be safe to wash or dry cleaned, or will doing so reduce the damage protection?
Yeah, that's a great question, Kyle. To be completely honest, I'm not sure about any sort of arc flash suits. I'm not completely sure how those are supposed to be laundered. Again, what I would suggest in any case, whatever PPE that you're wearing, that you look at that care label, that manufacturer's care label, and follow that appropriately in order to guarantee, that your level of protection is remaining intact.
So again, just close examination of the products that you're buying and what their care requires.
Absolutely, absolutely.
Okay. Now, these garments can be worn in a variety of environments, including outdoors in the summertime, and there may be situations where workers are applying sunscreen to parts of their body. Does that negatively affect the FR fabrics?
Nope. Sunscreens are perfectly okay to wear. It's really just the DEET and an insect repellent that you need to watch out for, because that is an accelerant that can act as a fuel, but otherwise sunscreens are perfectly okay to wear.
Okay, great. Now, are there lists available that contain the equivalent FR rating for layering with specific PPE clothing?
Yeah, great question. Really, that's up to the garment manufacturer. There isn't like a list online where you can see exactly what layers are going to work. I will say in any of the larger garment manufacturers, most likely they've conducted some of this layer testing that I talked about. So I would encourage this person or folks that are interested in that to reach out to their garment manufacturer, and I'm sure they can provide them with the list of which combinations work, and what that arc rating would be as far as being worn in a system.
Okay. Now, kind of a similar question. Is there a complete table available for selecting HRC levels based on voltage or conditions? This individual is interested in putting labels on their panels and breakers.
Yeah, sure. I would suggest that person looking at NFPA 70E. I believe it's table 130, and that is going to give you a list of exactly what I showed you on the screen here, which I showed you just a very small snippet, but it's going to go through and break down each task that a worker would perform so that you know exactly what's required depending on the task. So I would suggest that person reference 70E.
Okay, great. Now, we have some compliance-related questions that are coming in. Maintenance personnel, do they need to wear FR clothing in a situation where they're not accessing electrical boxes, but they do lock out factory machines. So is FR required or recommended in those situations?
I would assume if anyone is within the boundary of an arc flash after you've performed your hazard risk assessment, whether that be maintenance workers, whether they're in there for 2 minutes or 20 minutes, then they should be wearing the appropriate PPE if they are within what's called that arc flash boundary. So I would say, I don't know the specifics on this situation, but I would say yes, if they are performing some work within that arc flash boundary, then they should be wearing the appropriate PPE at whatever HRC level is required within that boundary.
Okay. Now we had a similar question, and I'm guessing you may have a similar response for workers who walk through electrical rooms. They're not working there; they're walking through them, perhaps as a daily inspection. Do they have to wear FR clothing?
Oh, goodness. As a daily inspection. That's a good question. You know what? I would probably say to be on the safe side, anytime you're within that arc flash boundary, you're probably wanting to wear a good level of protection that's required. But I don't know as far as what the standards say. I'm unaware of anything where the standards talk about just walking through a room, whether you need to change. I believe it's more just of a worker who's going to spend a little bit of time in there doing some work with the equipment or whatnot. So it probably is okay if you're just walking through the room, that you probably don't need to then change into some sort of arc flash PPE.
But again, it's not a bad idea to err on the side of caution either, correct?
Absolutely. I'll tell you, if it was me, I'd probably err on the side of caution and probably wear it, because you just never know. So absolutely.
Great. Now there are some questions that we have regarding the clothing, and you mentioned the clothing that you wear underneath your FR material. It doesn't have to be FR clothing. It can be regular cotton shirts or whatnot, but avoiding synthetics. Now we had a question here about blended fabrics. What about something that's, say, 98% cotton and 2% synthetic? Is that okay? Or again, should you just err on the side of caution and avoid any percent of synthetics?
No, I would say that's a great question. And actually, you'll see that even in FR arc-rated fabrics, some of them use some synthetic blends. So what it is it's really just, as long as you have a small portion, a very small percentage of that synthetic where they've added it for some, for stretchability, for some sort of comfort reason, but it doesn't affect the overall performance. In the case you're talking about, a 98% cotton and a 2% poly, most likely that fabric blend is not going to melt and drip. It's going to take on the properties of cotton. So you're probably okay there. But I would say, with that said, it's probably best to just err on the side of caution. I wouldn't push it too much, but I think a 98% cotton, 2% synthetic blend is probably okay. But I wouldn't push it any farther than that. The biggest issue is that a lot of those, Under Armour style, athletic, base layer moisture wicking shirts that a lot of guys like to wear, those would be an absolute no-no to wear, because that's absolutely going to melt and drip and create a much more intense injury versus somebody who's just wearing a cotton base layer. So. Okay.
Great. Now you talked about layers earlier and how to layer certain clothing, and you gave an example there of I think it was a sweatshirt and a jacket. But what about type of layering that should be done for the head and face if they want to obtain a Category 4?
Oh, goodness. Typically, the standard doesn't really address anything to layer up for your face. If you need a Category 4, you're most likely in an arc flash suit, so you're probably wearing a full-blown suit with the hood, so there's probably not a lot of layering that's going on in that sort of instance. I would say if you are going to be wearing, and maybe this doesn't really answer the question, but I would say if you are wearing FRPPE at a certain level, HRC level, then you should pick accessory products that meet that same level. So for example, if you need to wear an HRC level 2, and you're wearing HRC level 2 coveralls, then you want to add a cooling bandana to that. I would suggest that you find one that also has the same HRC level 2 on it. But in the case of an HRC level 4, most likely those folks are wearing a full-blown suit. So layering is probably not really what they're looking for.
Okay. Now, I wanted to talk a little bit about the garments and kind of the labeling of it, and you touched on this a little bit, but I was hoping you can go into a bit more detail. Are garments required to have an additional label that is in addition to the care tag that indicates the HRC level or that it meets certain certifications?
Yes. Absolutely. That's part of being certified to ASTM 1506, and in that standard, it actually lays out exactly what you need to have on your label. So manufacturers that are saying that their garment meets that standard is also going to have a label that complies with what the standard says. Typically what that includes is it will say on there that this garment meets the performance requirements of ASTM 1506. It could also say it also meets an FPA 70E, and it will provide you with the HRC level, whatever that is. It will also give you the ATPV or the EBT rating on there, so you'll have that cal per centimeter square rating. It also is required to have the care instructions. Like I said, that's really important. Proper laundering is very important in order to ensure lifetime protection. And then it's also going to give some sort of tracking information on there too. So if there is an issue that the manufacturer needs to take care of, then they know what fabric lot that goes with and all of those good things. So absolutely. And again, all of that would be captured in ASTM 1506 standard, in that standard.
Okay, great. And we have one last question. I was hoping, again, you touched on this a little bit during your presentation, but perhaps you can go into a little bit more detail regarding how an FR garment should fit. Should workers go and get it, almost get fit tested, as it were, to make sure it's appropriate fit and they have all the functionality that they need, or what are some rules of thumb they should keep in mind when they're putting on their clothing?
Yeah, I would say a good rule of thumb is the looser fitting the FR garment, the more thermal protection that clothing system is going to provide. Again, I talked about how air is a very effective insulator, so maintaining that air gap between the clothing and a person's skin is going to reduce that rate of heat transfer, and then it's therefore going to reduce their rate of injury. I would also say, too, that making sure that your collars are worn closed, that your sleeves hit to, people aren't rolling up their sleeves, so you have exposed skin. They're not rolling up their pant legs so that they have exposed skin. All of that, of course, is going to lead to higher burn injuries. So all of those sorts of things as well, when we talk about a fit of a garment, is really important. So, and then, of course, you want your garment to fit so you can wear it and move and do what you need to do, and it's not tight and uncomfortable. So.
You mentioned the importance of making sure it was loose for those air pockets. Is it possible for a garment to be too loose? Does that cause problems?
Absolutely. You want it to be balanced, of course. Obviously, especially if you're working in equipment where you've got moving equipment, you don't want it so loose that it's going to get caught in equipment, and then you have a whole other hazard on your hands and a whole other injury on your hands, of course. So there's obviously a balance in there, but I think you definitely don't want it. It's not a compression fit. It's not a ribbed fit type of a garment. You definitely want to have some air pockets in there so that you can get the most protection, maximize your protection, if you will.
Okay, great. Well, unfortunately, we are running out of time. I apologize. We did receive a lot of questions that we did get a chance to answer during this Q&A, but as a reminder, all of these questions are going to be forwarded on to Adria. Once again, I hope you take the time to fill out our evaluation survey on your screen to give us your feedback. And with that will conclude Safety and Health's magazine webcast. I'd like to thank Adria, Ergodyne, and all of you who listened in. Thank you, and have a